Quadrilateral land. What is a quadrilateral? Four sides. Any four sides. Within quadrilaterals, we have more specifically parallelograms. And parallelograms have two opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. So parallelograms, specifically two sets of parallel sides. So great thing to remember. Today we are getting even more specific with properties of rhombi or a rhombus. Rhombus. A rhombus has a few extra things. Rhombi is plural. So a rhombus has a couple extra things, and the very big one to note is that all four sides are congruent. All four sides are congruent. So what shape are you thinking of if you have four congruent sides? A square. A square is an extraordinarily specific rhombus. So I'm going to make it a little different. I'm going to say that this shape, kind of like a diamond, is what we call a rhombus. That is the mathematical name for it. It has four congruent sides. And so all of these happen to be the same length, okay? Not only are the sides, all four sides the same length, the diagonals are perpendicular. The diagonals are perpendicular to each other. So if I were to draw in diagonals, what else should I add to my picture here? 90-degree angles. Those diagonals intersect and form four 90-degree angles. And of course, if we have all of these little right triangles, well, they all equal 90 degrees. All those little angles equal 90 degrees. But we have these little triangles here. What theorem do we, Pythagorean theorem, yeah, we probably are going to use the Pythagorean theorem because we have right angles, okay? Let's see, we also have the diagonals bisect opposite angles, which is very interesting. The diagonals bisect opposite angles, which is important because we already know that opposite angles are congruent. So if this angle up here is 80 degrees, what's this angle at the bottom? Also 80 degrees. Now, in addition to those opposite angles being congruent, that diagonal bisects. The diagonal bisects each of these little angles. So what is each little baby angle? 40, yeah. I wouldn't call it that, but it's just there's a lot of symmetry. Okay. So that says 40. I know it's really small. I apologize. So we got little 40-degree angles there. Now, ladies and gentlemen, if this top angle is 80 degrees, what's this angle measure on the right-hand side? 100. 100 is correct. How did you figure 100? Yeah, because they are supplementary. Consecutive angles are supplementary. So the 80 plus the 100 gives us 180. And that diagonal bisected this 100-degree angle. So what's each little baby? 50 and 50. Okay. So good things to keep in mind. Let's look at number 2. Each quadrilateral below is a rhombus. Ladies and gentlemen, please read. In Delta Math, you need to read the directions. You need to understand, am I looking at a rhombus, a parallelogram, a rectangle, because they all have different properties. You need to keep them straight. I have a rhombus here, and what's really important about a rhombus? 4 equal sides. Very good. All right. So if EF is 23, what do we know? GF is 23, DG is 23, they're all 23. All right. DF is this whole diagonal. What do we want to do with that whole diagonal? Split it in half, because if we have a diagonal, we know that they bisect each other, so diagonals are going to get cut into, in this case, a length of 20 and 20, which means HF is 20. All right, what else do we know about rhombi? All four sides are congruent, but also the diagonals are perpendicular. And I need to find this side GH right here. How do I figure this side GH? Pythagorean theorem. Good. We have leg squared plus leg squared equals hypotenuse squared. So I'm going to do 20 squared plus GH squared equals 23 squared. How do we solve this? Good. We're going to subtract that 20 squared. So we're going to do 23 squared minus 20 squared. So that gives me GH squared equals 129. And then square root both sides. So we get 11.4 if we take a square root. So GH is 11.4. So I'm going to write that in 11.4. So that little baby diagonal is 11.4. What about the other side of that diagonal? Same thing. It is also 11.4, which means GE is 22.8. How'd you get 22.8? Added it up or doubled? Added 11.4 twice or double it? Same thing. Questions for me? This is a lot the same, right? Let's look at number 5. All right, number 5. You are way too interested in your computer. Close your screen.
Games. Yeah, that's educational.
So again, I have a rhombus. What do we know about rhombus? All four sides are equal and perpendicular diagonals. Good thing to remember there. So we have ZY is 34. ZY is at the bottom, 34. What's WZ? Also 34. Just like all the other sides. All right, let's see. They also told us that WY is the whole diagonal. It's 38. What should I do with that whole diagonal? Split it in half. Divide it by 2. What is 38 divided by 2? 19. Very good. So each little baby diagonal is 19, which means VY is 19. Okay, how do I find ZV? ZV is right here. Pythagorean theorem again. Very good. So what should I write? That is what you're going to do. I'm going to write ZV squared plus 19 squared equals 34 squared. Leg squared plus leg squared equals hypotenuse squared. Again, we are going to subtract that 19 squared. So 34 squared minus 19 squared is 795. And then we're going to square root. And so ZV turns out to be 28.2. Okay. So ZV is 28.2. I'm going to write that in, 28.2. If that little baby diagonal is 28.2, what's the other diagonal? Also 28.2. So what's ZX? 56.4. How'd you get 56.4? Add them up or double? Double the baby? Double the baby. All right. Okay. ZXY. ZXY is this angle right here, and it is 34 degrees. What do we know about the opposite angles in a rhombus? They are the same, but also The diagonals bisect those opposite angles. So what is WXZ? WXZ? Right here?
34.
Same, 34. Good. If these at angle X, both of these are 34, what is the whole of angle X? 68. All right. What's the whole of angle Z?
68.
Also 68. And what's each little individual angle down here?
34.
Also 34. Good. Okay. So lots of 34s there. WVZ. WVZ. Ooh, they're right there. WVZ. Yeah, 90. That's in the middle here. So that's 90. ZYW. ZYW. Ooh, we want to know this angle right here in purple. How do we figure out that little purple angle? Good. You're seeing this little triangle right here. We know that that's supposed to be 180 degrees, so we can do 180 minus the 90 minus the 34. And that gives me 56 degrees. And then we want to know XYW. XYW, that's the other side. What's its adjacent angle? What is it? Also 56, yes. Yeah. Okay. Again, all those little angles get bisected, so they're all the same. All right, questions for me on that? Good. Let's turn the page. Okay, so a square is the most specific quadrilateral that we have, and it is the properties of all of the things we've been talking about. It has two sets of parallel sides. It has the properties of a rectangle. That their diagonals are congruent, and that we have right angles, just like a rectangle, and the properties of a rhombus where all four sides happen to be the same length. The diagonals, as I said before, those diagonals are the same length in a square and in a rectangle. Those diagonals match. They still get bisected into little congruent babies, okay? And they intersect at right angles. Those diagonals do a lot for us. They also bisect the corners. If we know our corner is 90 degrees and our diagonal bisects it, what is each little baby angle down here? 45. All right, so all these little baby angles are 45. So let's look at number 6. ABCD is a square, and AD is 11. What else do you know if AD is 11? The rest of them are also 11. Okay. We also know our corners are 90-degree corners. So BC is 11. But I need to find AC. AC is the diagonal. How do I find the length of the diagonal? That's true. It is the 45, 45, 90, which is the easy way to do it. But we're not going to do it the easy way. You're exactly right. You know the hypotenuse already? You don't? Okay. It is a 45, 45, 90. Find the hypotenuse. It's not 77. We have a right triangle, do we not? All right, so leg squared plus leg squared equals hypotenuse squared. Leg squared plus leg squared equals that AC squared. All right, 121 plus 121 is 242. All right, and then we need 2. Square root both sides. Let's square to 242. 15.6. Beautiful. All right, if the diagonal is 15.6, what is BD, the other diagonal? Also 15.6. The diagonals are congruent in a rectangle. EC, what is EC? How'd you get 7.8? 15.6 divided by 2, 7.8. Very good. Those diagonals get bisected. Great. DAB, angle DAB is what? 90 degrees. 90 degrees. Good. Angle AEB. AEB is also 90 degrees because it's that little angle there, AEB, where the diagonals intersect. They are perpendicular. They're also 90 degrees. CBD. CBD. That's this guy right here. 45. That's right. 45. Very good. And BAC. BAC is just this guy here. What's he? Also 45. Okay, great. Any questions now? Is this easy or hard? Pretty easy, yeah? Okay. Let's look at number 9. All right, CDEF is a rhombus. And we have information about these little baby angles here. What do we know about these little baby angles in a rhombus? They are equal. They get bisected. Those diagonals bisect the angles. So what equation can we write? 5x plus 1 equals 8x minus 20, because those angles are congruent. I'm going to subtract 5x and get 3x. I'm going to add 20 to get 21. And then we get x equals 7. Beautiful. Okay, so I solved for x, but my job is to figure out the measure of angle FED, which is this whole angle right here. What do you got? Subtract it from 180 because they're supplementary. These consecutive angles are supplementary. So we can go ahead and plug our x in here. So 5 times 7 plus 1 is 36 degrees. So this angle is 36 degrees. What's his adjacent angle? Also 36. So what is this whole angle F? 72. Okay. So then the measure of angle FED is going to be 180 minus 72, which is 108 degrees right there. Okay. Questions for me? No? All right. You guys have adults math, which I think posted 1 minute ago. Yeah, that's good. All right.